Hello and welcome to Trigonometric Identities and Equations, Chapter 6 of P2. We are starting with trig and unit circles and how we can use the unit circle to find different values of sin, cos and tan. Just to start off, a unit circle is a circle with a radius of 1. That's it. That is what a unit circle is. It has a radius of 1. And then for any point P on the unit circle, so on the circumference of the unit circle, so any point P around here, such that OP makes an angle theta with the positive x-axis. So we're always starting here and measuring our angle anti-clockwise from the positive x-axis. So even if we're going all the way around into this quadrant here, we're always going anti-clockwise and starting here on the positive x-axis. So for that point, then cos theta is equal to x, so the x coordinate of that point. Sin theta is equal to y, the y coordinate of that point, and tan theta is equal to y over x, so the gradient of the line, so this line. And then we can use that to find certain values of sin, cos, and tan. There aren't many that we have to actually work out, because then you would just use your calculator, but there's some key ones that you can see quite easily from the unit circle and that come in quite useful when we're looking at identities and trig equations and things. So let's have a look at how we can work some of these bits and bobs out. So there's our unit circle. And we want to find sin 90. So an angle of 90 degrees means we have started here at the x-axis and we have measured 90 degrees, which takes us to the y-axis. So sin is our y number, the y coordinate, sin is y. So when at that point, so if we have an angle of 90 degrees starting from the positive x-axis, we are now on the y-axis. Our point is here where the circle meets the y-axis, and our y value would be 1 because it's a unit circle. This line here would be a radius, so it's 1. It's going to cross at 1 on the y-axis. It would cross at 1 or negative 1 at all points on the axis. So it would cross y at 1 and negative 1. It would cross x at 1 and negative 1. So that's nice and easy. Sin 180, change colour. Then we're starting again at the positive x-axis and we're going anti-clockwise. 180 degrees takes us to here. So now we're on the x-axis. We're looking at this point here where the circle is crossing the axis. At that point, our y value is 0. It's crossing the x-axis. Any point on the x-axis has a y coordinate of 0. So sin 180 is equal to 0. These would be easily checked on a calculator. Just put that out there. You could easily do them on the calculator just to check that you're getting it right. I'm going to change colour again just to keep so it doesn't get too messy. The next one's sin 3 pi over 2. So notice that changing between radians and degrees as well. They seem to do that. They're kind of quite quick to change between the two in P2. They'll expect you to be able to work with both. I tend to find it easier to change the radians into degrees in my head just because that's what I'm used to, but it's entirely up to you. 3 pi over 2 would be 270 degrees, wouldn't it? Pi is 180, half it is 90, 2 times it by 3 is 270, yeah. So we're starting at the positive x value at x-axis and going anti-clockwise 270 degrees or a 3/4 turn takes us to here. Our y coordinate when the circle is crossing the y-axis here, the y coordinate would be -1. So sin 3 pi over 2 would be -1. And then the last one for sin is sin minus pi over 2. So pi is 180 degrees, half of that is 90 degrees. Because it's negative, it means we're going clockwise instead of anti-clockwise. So starting at the positive x-axis and going 90 degrees clockwise would take us to here. So it would actually have the same value as 3 pi over 2. Takes us to the same place because we're going in opposite directions. So this would be -1 as well. And again, like I say, you could put all of those values into your calculator, making sure you're in the correct degrees or radians, of course. But those are the values you would get. But they are just easily seen from the unit circle and the angles measured from the positive x-axis. Let's have a look at some cos ones. So cos is the x value. So cos 180 means we are starting here and going to there. Our x value, where the circle is crossing the x-axis, the x value would be 1. So cos 180 is 1. Sorry, -1. Yeah, because it's in the negative direction. Cos minus 90, now again, we're starting at the positive x value, at the positive x-axis and going clockwise this time instead of anti-clockwise because it's -90, which means we're going to here. Our x value, where the circle is meeting the axis, it's crossing the y-axis. Any value on any coordinate on the y-axis has an x value of 0. So that would be 0. Cos 3 pi, now a full term, 360 degrees is 2 pi. So 3 pi means we're going a full rotation and then another half a one. I'm not going to draw it on both, but imagine we're starting here. This would be pi, this would be 2 pi, 3 pi takes us back to the same as the first one. So it's actually cos 3 pi gives us the same value as cos 180. So it would be -1. And then the last one, cos 5 pi. Now again, that is more than one full rotation. So this would be pi, 2 pi, 3 pi, 4 pi, 5 pi. It's the same value again. It's still crossing the y-axis in the negative side, so it would be -1. Yeah, and that's it. That's the basis of what you need to know for sin and cos. For tan, obviously we said that the value is found by the gradient of the line. So they're not going to give you anything that is difficult to find the gradient. There'll be ones that are easy to see. So gradients of 1, -1, 0, and undefined as well, which kind of links back to why tan has an asymptote, and there are values of tan that are undefined that don't work because the graph of tan doesn't actually cross certain values from the x-axis because there's an asymptote. So tan 45 means that our line is starting here and is looking something like that. Because it is at 45 degrees from the axis, that means the gradient's 1. It would be the same as the line y equals x that goes at a 45 degree angle through the origin. So the gradient of that line is 1. So this would be 1. Tan 45 is equal to 1. Tan 135 would be just had a bit of a mind blank there. Tan 135 would be would be there, right? Why is it saying it has a gradient of 0? Why does it have a gradient? No, that was wrong. Yeah, confusing myself. The example in the textbook says the answer 0, and it's definitely not. I checked it on the calculator. It's -1. So again, 135 would be, it's 45 degrees between the positive y-axis and the negative x-axis. So like this would be 45, and so would this. It's still halfway between the negative x side of the axis and the positive y. So it's a 45 degree angle, so the gradient is -1, not 0. And the textbook's wrong. It's so unusual. The textbook's never wrong. It's unusual that it's wrong in an example though. Tan 225, so that's going 180 and then an extra 45, so that is down here. Again, it's 45 degrees between the negative x and the negative y, so it's a 45 degree angle. It's a gradient of 1 again. Again, that would be the line y equals x. Tan negative pi/4 is -45, which takes us to down here. So that is again a gradient of -1. Tan pi is 180. Pi is 180 degrees. So that would be over here. Now the gradient there of a horizontal line, because we're looking at this line here, the gradient of a horizontal line is 0. So the gradient there would be 0. Tan pi is equal to 0. And then tan pi/2, so that is 90 degrees, takes us up to the vertical. It takes us to the y-axis. Now a vertical line has an undefined gradient, so that is where the undefined comes in. So anything with a vertical gradient, we say that is undefined because it's like infinite. Yeah, and that's it. That's the first part of this chapter done. It's pretty straightforward once you kind of wrap your head around that you're always starting from the positive x-axis and always measuring your angle anti-clockwise. Then it's pretty straightforward. Cos theta is x, sin theta is y, and then tan theta is y/x. And like I say, they're not going to give you a gradient that's tricky to work out. It'll be something that's obvious, like a gradient of 1 or -1 or 0 or something. Yeah, the next video is all about the signs in each of the 4 quadrants. So where like sin is positive or negative and so on. So that's what we'll look at in the next video. But that's the first part done. Not too painful, I don't think. Okay. Thanks for listening, watching, and have a lovely day.